And the whole reason for that is illustrated very well in the diagram. You have two suppression teams that set up on the fire floor, connect to the standpipe, and when they charge their 30 meters of hose, or to 60 meters of hose in some cases, and there's two lengths of that hose, it gets rock hard, and at that point, that stair is impassable at that point. So that's why you need a third stair. However, if we're going to be moving all or most of the occupants out of the building by elevators, and the elevators become the primary means of egress, then it's probably not necessary to increase the size of the stairs, and the 1100 millimeter current standard is probably going to be good enough. There would, however, be capacity reductions in the amount of minimum capacity you would have to provide if you're using elevators, with that capacity defined in terms of an assumed flow rate for people moving down the stairs. With regard to refuge floors, again, these become part of the entire system and need to be looked at as a system. Probably the most important advantage is the provision of crossovers every so often to allow people to change stairways if they need to, and some space to rest temporarily if they need that, so that they don't slow down the flow or block the stairway. However, the degree to which these extend total evacuation times need to be taken into account. It is, again, unclear whether people will delay egress in a real emergency. They, I think, will tend to want to get out as quickly as possible. Another aspect is real-time and proactive management of evacuation. Particularly in a very tall building, it's not a good idea to just ring the bells and hope everybody does the right thing. We're looking at in our codes development system at requiring video cameras to provide a look into the stairway every few floors, but this will require image analysis software that could flag problems without causing the fire department to have to watch all the cameras all the time. Communication systems that are already a part of the code and included in buildings and regular crossovers to prevent redirection of egress would round out this particular system. There are some other technologies that we should be looking at, and we are taking some looks at. RFID tags can provide tracking information with current technology, and also cell phones, since they all have GPS capability. If you had a system designed to track cell phone movement, as is being done with traffic today, you could look at flow rates in real time in the stairway by monitoring people's cell phone signals. So again, performance goals for egress for tall buildings: the ability to evacuate all occupants in a time equal to half the required fire resistance in the primary structural frame. Given code requirements of 2 to 3 hours for the primary frame, that would mean that you would evacuate the building in 1 to 1.5 hours. That can be done in any building that's properly designed with the elevator system without increasing the number, speed, or capacity of any of the elevators, because that's what they're designed to do in the first place. This would typically require elevators for buildings above about 50 stories, because below that you can walk down in an hour to an hour and a half. For fire service access elevators, that would mean above about 30 meters, following BS 5588 Part 8 or EN 8172, which is the new SEM standard version with the US modifications that we're looking at. And this would provide suppression operations beginning within 30 minutes of the initial alarm in any building. So in conclusion, increasing building height, changing demographics, and the availability of the technology to produce fire-safe elevators are very strong causes for a fundamental rethinking of egress that needs to take place for all buildings, and particularly for tall buildings. Whether the primary means of egress is by stairs or using elevators, a quantitative metric for timely full evacuation can be established as a matter of public policy and code requirement. And egress and access by elevator is highly desirable for tall buildings from the viewpoint of building owners, designers, occupants, and regulators, and for buildings of any height for people with disabilities. Thank you.